And we're live.
Hello.
Hello. So we're back after 2 weeks, 3-week hiatus.
Yeah, we took 3 weeks off because last week was bad for both of us.
Yeah.
So, but yeah, we're back and we're doing chapters 3 and 4 of book. What book are we on?
I think it's book 3. That's what I put anyway. I put part 1.
Book 3.
That's probably wrong.
Yeah. And chapters 3 and 4, which chapters 3 is objects and chapters 4 is why. Basically, why classes aren't a thing. So I'll start sharing my screen and we'll get started.
Cool. The last thing we talked about was this keyword, right?
Yes. Mm-hmm.
Okay, cool.
Let's see.
Set you to present. I think you're good to go, sir.
All right. Are you seeing the slides as full screen?
I sure am.
Great. Okay. Chapter 3 of objects. You don't know JS. This and prototype and object prototypes.
Okay.
So we have 2 kinds of objects. We have literal objects, which are like you write them out, and then you have constructed objects where you do like var my object equals new object. My understanding is that the literal is much more common, but that may not be the case anymore.
Okay. Yeah, I hadn't seen. So far in this book, we've seen literal, right? But we haven't seen that I recall the constructed.
Right. So I think that the new, which is like a constructor, I'm not sure how it behaves yet, and I don't know that he goes into a lot of detail yet, at least as far as we are, on the difference between the two. So we have the 6 types in the language: string, number, boolean, null, undefined, and object. This is a little bit of coverage of stuff we've covered before, but so string, number, boolean, null, and undefined are not themselves objects. They are
literal, or what do they call them?
They're like native types.
Yeah, native types. That's what I was trying to think of.
And functions are a subtype of object, and arrays are also a form of object. They're not really arrays.
Okay.
So like, we'll get into that in a little bit, like how arrays can have both object and array behavior. So objects with built-in constructor. So here are the objects with the built-in constructor functions: string, number, boolean, object, function, array, date, regular expression, and error.
Okay.
And I know I said on the previous page that they are not themselves object. String isn't, but like I don't remember why he said that, but yeah.
So maybe it simulates an object, but it's not actually an object or something.
Well,
like
strings have prototypes and stuff, so I'm not sure. But so they all have a built-in new function that's defined on them. So that's the constructor.
Okay.
You could do new on each one of these. So literals and constructed objects, if you do var string object and you said equals new string and then you pass it an argument of a string, that is not the same thing as var. Oh, did I accidentally copy it?
It looks the same.
Yeah, I meant string primitive. Yeah, so string primitive would actually be just var string primitive equals I am a string. Sorry.
Oh, okay. So without the new string thing.
Yeah. I messed up my slide there. Sorry.
Okay, so
string.
So
string primitive is not an object. That's right. That's what it is.
So that's like C# and Java, I believe, as well. But I might be wrong about Java, and nowadays I might be wrong about C# as well. But there's a native type for string, and then there's also an object for string, and you can box it and unbox it, and it converts them back and forth. But they are actually 2 separate things. I might be wrong about that, but there is such a thing as boxing with native types in C#.
So that sounds right. So there, I fixed that slide since we were discussing that. That makes more sense. So those are not the same thing. So string primitive is not an object. It is a string literal, and it is immutable. String object is a constructed object of the string type. So it
that makes
is
sense.
an object. Does that make sense?
Yep.
Okay. All right. So JavaScript.
So, yeah.
Go ahead.
They're two different things. They just have the same, I guess same name, but they're they're not exactly.
They're
the
built
same.
differently. So is there a rationale for like having this difference, in the language?
So, at least what I've understood in the past is that the primitives are faster, especially if you just have small strings that you're doing stuff. Although, because they're immutable, you can't really do a whole lot with them, and you'd need to use something like a string builder in C# to work with them. But yeah, the idea there is that you're not allocating any memory on the heap for a primitive, and if you're crunching a whole lot of them, that can make a difference. But if you are just wanting to have the convenience of, being able to call methods on a number or a string, then you're probably going to want to have the object version.
Okay. So, then we'll continue on. JavaScript, it will coerce a string literal into a string object when it needs access to the methods defined on the object.
Okay.
So, and then when possible, prefer literals over constructed objects. At least that's what this book recommends. Which would make sense based on your thing about literals being less memory intensive.
Yeah, because they don't need to allocate; they just go directly in the stack.
Right. So literal coercion and constructors. This coercion from a literal to an object happens with number and Boolean literals as well, not just strings. Null and undefined can only be literals that don't have constructors. Date values can.
Why would you construct null?
Date values can only be constructed. They don't have a literal form. Object, array, function, and regular expression all let you build them with either form, but they're still objects. They're all still treated as constructed objects. There are special rules here for why you might use a constructor. I don't think go into a lot of details about what the rules were, or if he did, I don't know.
That stuff's usually pretty nitpicky.
Yeah, errors are rarely explicitly created, but they can be constructed.
Okay, so like new something error or whatever.
Yeah. So yeah, that's my next
confused yet? Actually, this kind of made sense just based off of working with some other languages, but
okay, yeah, well, yeah. So this is probably inheriting stuff from like the C# world
or something. Yeah, it's or Java, because C# came from Java.
Okay, so yeah, the Java world. So yeah, and this is all like, I'm not coming from that world. The world I'm coming from is the Smalltalk and Perl and all that stuff world. So
right, but you mentioned XML earlier, so you're headed directly into that world.
Yeah. So object contents, the contents of wow, I was not paying attention when I made these slides. The contents of an object are values of any type stored at specifically named locations. So think of like a hash map, basically.
Yep.
So one of the nice things about that is you can pass around. You can. So if you look at the second example there, var 1a equals true, var my object equals a2. And then you do var index if 1a index equals a, and then you do console.log my object index and you get 2. So it actually takes the index string and passes it to. So 1a is true, so it sets index equals the string a, and when you do console.log my object index, it passes the a string in and calls the 2. So you can pass in values as strings and things like that because of the way you can call. You could do the hash style calls or the dot calls, and the hash style calls let you pass in other things that represent a, that point to a.
Okay.
Does that make sense?
Yeah.
Not too complicated, but yeah, it's just a thing to notice that there's a reason why you would have the hash style. Object contents. So var my object equals an empty object. My object true equals foo. My object 3 equals bar. My object equals baz. That one threw me. So my object true, if you call it with a string, you get foo. If you call my object 3 with a string, you get bar. And if you call the string interpolation of object, of an empty object into, or yeah. If you call like my object to string in JavaScript, you get the object thing.
Interesting.
So, property names are always converted to strings. So it converted my object to the string.
Okay.
And so if you pass it the string, you get the same results.
And that's probably because of the way that it can be interoperable between the two different function call styles, and that's why it's a string.
Well, I think what it's showing here is that when you set a value, like my object true, it converts the true to a string.
Okay.
So you can call it. So it coerces like my object to a string, and so when you coerce my object to a string, you can later pass the string of that as the call, and it'll work.
Okay. I see.
Yeah. Computed property names. So var prefix equals foo, var my object equals prefix plus bar is hello world, prefix plus baz is world, sorry. And then you do my object foo bar and my object foo baz, and you get hello and world.
Okay.
Seems pretty straightforward.
Yep.
But yeah, that's kind of a cool, because that's actually what a string means. You get that to work.
Yeah. Huh.
The little like array types construction inside of the key was throwing me off, but
yeah. Huh. Okay.
I could get used to it.
Yeah. It's kind of neat that it's string manipulation to manipulate object things.
Yeah. So property versus method, because sometimes people like to distinguish the two.
I would think that's kind of blurry in JavaScript, but my guess is that functions, if you assign a function, it's a method. If you assign a value, it's a property.
So it isn't particularly, so this is what the book says, it isn't particularly useful to draw distinctions between properties on objects that are data and properties on objects that are functions.
Okay.
Functions don't actually belong to objects. They just have a name defined on them that point to the function. So it's pointers that are defined. It's like it's reference. It's not a copy.
Yep.
So function and method can be treated interchangeably.
It's interesting. It goes against a lot of my OO training.
Yeah. So Ruby, because I'm coming from Ruby doesn't have like a real distinguishment between functions and methods either. Ruby doesn't really have anonymous functions. Like it has lambda.
Yeah, the functions are methods. You just don't really know it, right?
Right. And so everything's a method in Ruby that gets treated like a function, except for like special case things like lambdas.
Yeah.
So like procs or whatever. Arrays are objects that have the array access defined on indices, the bracket.
Yeah.
That can also get properties defined on them. You have to pay attention.
You can define a property on an array?
Yeah. So what is the length of the array on the left?
On the left?
After both lines run.
After both lines run? 4. Because .baz is the same as referencing the baz element on the array object, is my guess.
Nope.
No? Dang it.
Still 3.
Still 3.
So let's look. Let's let's do it real quick. Because I knew when I did this, I didn't realize how long it was going to be, but I knew when I did this, it was just going to be just as easy to do. Well, let's just try it out and find out kind of situation. So var my array equals foo 42 and var my array dot baz equals baz my array dot length.
But why?
3. Because it doesn't actually insert the baz into the array, because it's treating the array like a hash. So the array is by
but
index.
hashes are objects, and objects you can use the dot notation.
Yeah, I know. Yeah. So that's what I'm saying is that arrays are weird.
Okay.
In JavaScript. So okay, now what's my array dot 3?
On the left?
Yeah.
I guess it's going to be what, bar?
I'm guessing it's going to be undefined.
Oh, 0 indexed in JavaScript?
Yeah.
Okay, then yeah.
An expected number. And then if you do my array and do 3 as a hash, it's also gonna be undefined. Yeah, so it's a syntax error on that when you do the dot 3. So now let's do the one on the right.
Okay.
So var my array equals foo 42 bar. My array with the hash of 3 equals baz. What's that link's gonna be?
I no longer have any idea.
I'm
going to say that it's going to be bar. Or no, sorry.
My array dot length.
My array dot length. I'm going to go with 4.
Yeah, I think it's 4. And then why do I got errors popping up here? Anyway, and then what is my array dot 3?
Baz?
I think it's going to throw an error still. So var my array.
These don't make any sense.
Equals, yeah, that's what I'm saying. So it's all array foo blah blah blah. So my array 3 equals baz. Baz is not defined. Oh, let me make baz a string real quick. Okay, my array 3 baz. So then we'll do my array dot length. It'll be 4.
Okay, so it did add it to the array.
Yeah, my array dot 3 is still an uncaught syntax error, but my array 3.
Because we're not referencing it with the brackets.
But my array 3 is going to be baz.
Okay. I guess that behavior makes sense. It's just that the other behavior you would think makes sense based off of what we've learned so far.
Right. Yeah. So arrays are objects with special behavior.
Okay.
So like they don't have some behavior and they do have others.
Yep.
So like you can define the dot stuff on them. If you define them with a dot, then they have the dot style access. So you have to kind of be careful though. If you define something with a dot and then you access it with the index style, you could things get hinky.
Yeah, I would think so. So is the reason you can define something with the dot because
arrays are just another object? Yeah, arrays are objects. So they get the
I don't like that.
No, I don't either. But JavaScript.
Okay.
Okay, duplicating an object. So since my object contains, okay, here we go. So we're going to try to duplicate an object here. And in JavaScript, that is a hard thing to do because it's actually, JavaScript stores references everywhere. It doesn't actually make copies of the object. So if we do like function, another function, and it's just some object, and then we do var another object equals C true, and then var another array equals an empty array, and then we do var my object equals A2 B another object. That's a reference to another object, not a copy. And then C another array is a reference to that array, not another copy of the array. And then D another function is a reference to that function. It's not.
Which makes sense. That makes sense.
Yeah. So what happens when you do another array dot push another object, my object?
Another array dot push another object.
Or it's referencing itself.
I have no idea.
Yeah. So since my object contains references to another object in another array, it isn't clear at what level the copying should occur if you were going to do copying. So it doesn't do copying, it just stores the references. Deep copying creates an infinite loop of references when you push an object that references the array that is being pushed to. What level to break that chain is not agreed upon. Also, since functions aren't, quote, defined on objects, duplications of functions doesn't even really make sense.
But, so what does it do?
So it just stores references all over the place. So like another array dot push, you're just storing a reference to another object and then a reference to my object, and another object stores a reference to the C to an the B another object stores a reference to another object, and the C another array stores a reference to another array. It just stores references all over the place. There's no duplication.
Okay, and that way it doesn't have to keep going.
Right. So it's actually easier to reason about in this case.
Right.
Because you're like, oh, it's just referencing where it's actually getting defined.
Yep.
So duplicating an object. ES6 solves the problem with shallow copying. It does do shallow copying.
Okay.
So function another function, var another object equals C true. We got the exact same thing. And this was, so I was showing you the previous page. This is exactly the same as the previous page on the left. On the right, we have new object equals object.assign, and you assign it an empty object and my object.
Okay.
And then it says new object.a. That's going to be true. New object.b equals another object is true. So it actually does create like a copy, but it's creating a shallow copy. Like all the references still point to the same. All the stuff inside are still just references.
Okay. Which I don't know that I understand why that's useful, but
I don't either. But so
okay.
So property designator, since he has 5 distinctions between properties can be drawn. For example, so we have like whether a property is writable or not.
Okay.
So we just say my object equals an object with a key and a value of 2. And we say object.get own property descriptor, my object A. That's going to return the value is 2. It is by default writable. It is by default enumerable, and it is by default configurable. And what enumerable means is that you can use it in an iterator.
Okay.
So like if you call like for each on it, it gets used in the for each.
Okay.
So if we do var my object equals an empty object, and then we do object.define property on my object, and we define the key as A, and we say we wanted to have these properties. Say the value is going to be true, the writable is true, and the configurable is true, and the enumerable is true. That's exactly the same thing as just saying my object equals A2. Like the define property, that's the method you can call. But if you passed it those arguments, it'd be the same thing as just writing my object equals A2.
Okay.
So the thing on the left and the thing on the right are saying the same thing. You get the same result on the other end.
Okay.
So Writeable lets you have setters.
Okay.
So on a value. So you get setters and getters.
Okay. Which
So
I'm not a huge fan of accessors.
right.
I know why they exist, and I've never really had to use one the way they're intended. And well, maybe like once or twice, but when I did, it was so awful, I never wanted to do it again.
Yeah, you and I are in exactly the same situations. I am always an attribute reader guy. I never write setters,
Yeah.
almost ever. If I do, I usually actually write an explicit method.
Mm-hmm.
I don't just use an accessor.
Yeah, yeah, exactly. I'll use an explicit method because then I converted to doing it in the constructor, but then that interferes with TDD. So then I will create some other function that will set those values.
Right. But I usually don't just use an accessor that lets you do like this dot whatever equals this.
Right. Exactly.
Yeah. So you can, so here's how this works in JavaScript with whether or not an object is writable. So var my object equals an empty object. You can do object.define property, and you do values to. Writable is false, and configurable is true, and enumerable is true. If you set it writable to false, then if you do my object.a equals 3, it will fail silently, and it will not change it. If you use strict, it will fail with a type error.
Yay.
One more reason for always using strict.
Okay.
But apparently there was a window of time where ES5 was out, but use strict was well, I guess use strict is still optional. But you know, post ES5, you could do this without using strict, and it would fail silently, which seems horrible to me. Like I would rather have setters than have it fail silently.
Yeah, I would too. Failing silently seems like the worst possible thing.
Yeah. So here's configurable. And I wrote why because I didn't understand why you would
want to do this.
Yeah. So var my object equals A2. If you do my object dot A equals 3, then you get my dot, and you call my object dot A, you get 3, right?
Okay.
So that's normal. So we're going to do object.define property my object A. We set the value to 4. We set the writable to true, and we set the configurable false, and the enumerable to true. Okay. That means that if you go my object.a, it gives you 4. If you do my object.5, it gives you 5.
Okay.
But if you try to set configurable to true, it throws a type error. Because once you've made it configurable, once you've set it to configurable false, you can no longer make it
configurable,
not readable and not writable. You can't change anything once you've made it not configurable, except for the value. Yeah, you can access the you could do so like since it's still writable, you could still read and write from it, but you can't
modify its structure.
Can't modify whether or not it's configurable.
Right.
So you can't like set writable to false, for example.
That seems like a very un-Ruby-like thing to do.
Yeah. Well, it's just a I don't know why you would ever do. Yeah, configurable. Oh, here we go. Configurable equals false prevents deletion. So var my object equals A2, my object.a, delete my object.a, and then if you call my object.a, it's undefined because you deleted it. So, okay, so here we go. We do value. So if you look at my previous one, I had the Y on there because I hadn't got to this part of the stuff yet. I was writing titles as I read.
As you on the fly, yeah.
Yeah. So configurable, if you set configurable to false and you try to delete it, it still exists, which also to me seems like bad practice.
I think it's probably because JavaScript deals with web browsers and you don't necessarily know what the web browser is going to do because you're in an untrusted environment, but I could be wrong.
Maybe, but I still, if I tell something to delete something, I want it to get deleted.
Yeah, I would agree.
I don't want this like magical thing just sticking around. I look through my code and I'm like, Rob, delete it right there. Why does it still exist?
Yeah, it seems like any sort of exception that you make is going to come back and cause problems later.
Yeah. So enumerable makes sense. You set enumerable to false on a property to prevent it from showing up in for end loops. Set to default to true. That makes sense.
Okay.
So immutability-ish. There are 4 strategies for getting kinds of immutability in JavaScript objects. You can set writable to false and configurable to false, and this makes the property a constant. It also makes it where you can't delete it.
Okay.
So it's a constant you can't delete, which, you know, there's some use. I can see use cases for that.
Yeah, I don't. Okay.
Yeah. So second, we have object.prevent extensions, and you pass in the object you don't want to be able to get extended, and it prevents new properties being added. So it fails loudly in strict and silently in non-strict. So if somebody tries to like extend your object, it blows up. Which, okay, I can see that. Like, I can see security reasons and all kinds of stuff. Like, if I don't want some library screen with my object.
Right. Yeah, that's exactly your use case. You don't want someone coming in and inheriting some or prototyping, I guess, in JavaScript.
Whatever.
Your object and then mucking around at the inside and making it not work correctly.
Yeah, and if they try to do it, you want to know about it.
Yes.
So, and we have object.still my object. So it's the same as prevent extensions, but it also makes the properties no longer configurable. But you can still modify the existing values. So it says you can't make it no longer writable or whatever. You can't extend it, but you can still say like dot whatever equals this.
Right. Yeah, this all seems to be like environmental precautions. You don't know where your code's going to be, so make it strong type stuff.
Ruby has some of these things too. Like, so dot freeze, object dot freeze, same as still, but it also makes writable false.
Okay.
So yeah, it makes it
basically like don't ever modify this object.
Yeah. So it prevents extensions. You can't modify it. It's no longer configurable. It's a constant that can't change and can't be deleted.
So if you're bringing records back from a database, maybe you'd freeze them before you pass them off somewhere.
Yeah, maybe. Oh, and all of this is shallow. It does not affect the object references.
That seems
so
useful.
The object references another object.
So it'll always reference that other object, but that other object, unless it is also...
It's still mutable.
Yeah, it's still mutable.
So if you have a reference to another object that, like, let's say you have like an object that says like, you have an object and you have like the A is 3 and the B is some other object dot A plus 2.
Right.
And you call dot freeze, the plus 2 won't change. But if you do some other object dot A equals 5, it'll change your behavior.
Yeah.
And he said if you want to like super freeze everything, you have to recursively freeze all of the objects.
You just need to walk through them and freeze them all?
Yeah. Which also seems super dangerous.
Yeah, because you don't necessarily know what you're freezing.
Right. So, okay, now we have get. So one of the things, so calls on objects are like get calls, which if anybody has done any kind of like, so I think of this as like get and post in web world. Get and post in web world. Yeah, when I see a get, that's what I think of, is like get and post.
That makes sense.
So calls on objects do not actually hold the values they reference. They hold names that point to the values they reference. When you call a value, it actually makes what is known as a get call and looks for the value assigned to the name. So it has like a URL in the code. It goes and finds what URL it tells it to get and gets whatever is there and brings it back.
Okay.
That's kind of like how I think about that. Yeah, like that's the experience I have with that concept. So that all makes perfect sense to me.
Okay, that makes sense.
If you can't find it, it will return undefined. Okay, yeah, that was a 404 or whatever.
Mm-hmm.
Okay, so here we have some examples. So var my object equals a is undefined. That is the same it's same to the user, but under the hood it's different.
Okay.
Because you're actually pointing at undefined with a. So, like
because one is actually doing a get to end up with undefined, and the other one is actually directly referencing undefined. Is that right?
I guess, yeah. Well, they're both doing gets. The a is you're setting a pointer to undefined. The other one, it just throws undefined when it can't find.
Right.
What the get call is.
Okay. Got it.
So, okay, and of course, if we have get, we also have put.
Okay.
So upon assignment, behavior depends on if the property is already present or not. And then the rest of this is in quotes. So 1, is the property an accessor descriptor? See getters and setters section. If so, call the setter if any. Is the property a data descriptor with writable of false? If so, silently fail in non-strict mode or throw a type error in strict mode. And then otherwise set the value to the existing property as normal.
Okay.
So there's actually getters and setters later. So he talks about getters and setters later. So I probably was a little bit.
So first, defer to the accessor if it exists. If it doesn't exist, then check with your writable rules and do what's appropriate.
Right.
Otherwise, just set the value.
Right. That seems pretty straightforward.
Yeah.
Okay, actual getters and setters. So you can override the default value of get and set at the property level. It's not the entire object level in current versions of JavaScript when the book was written. Or possibly now. I don't know how recent, how up to date the GitHub is. But var my object equals, and then if you do get a, return this dot a, and then if you define a setter a, and it takes an argument of value, this dot a equals value times 2. So if you say my object dot a equals,
I was just going to say that's your typical code for a getter or setter.
That's a setter, yeah. I've never seen it constructed like that. So with like the get and the set and all that stuff.
It's really close to C#.
Is it? Okay.
Yeah. Well, before they made a shorthand for it, but yeah.
Okay. But yeah, so yeah, because I'm used to like def whatever and then def equal or def whatever equal to do the setter. But yeah, like that's fine. That makes sense. The underscore thing threw me for a second, but it's not hard to figure out what it's trying to do.
Yeah.
So yeah, anyway, this dot underscore a underscore equals value times 2. So if you set a to 2, then you call it, you get 4. It's normal.
Okay. Yeah, that makes sense.
So without a setter to return whatever the getter is, and fail silently when you try to call my object dot a equals whatever.
Okay.
So if you define a getter but not a setter, you'll fail silently when you try to call it with a setter. Try to call like whatever dot equal.
Oh, that's awful. It'll
I
fail
agree.
silently.
That's what it says.
Oh.
Maybe in strict mode it won't. I don't know, but
okay. Yeah, silent fails are just generally awful.
Yes, they're terrible things. they're like almost as bad as nil and Ruby.
As bad as what?
Actually, it may actually be a little worse than nil. Like I hate these. I love languages that don't have null.
Really? I love null.
Yeah. No, it's terrible. It's the cause of so many errors. Existence. So var my object equals, A2, same as the rest of the evening. A in my object, B in my object. A will, that first line will return true, second will return false.
Okay. Makes sense.
And then it's the same thing as my object that has own property.
Yeah.
And so in checks, oh, actually, so there's a difference. In checks if that property has the property available anywhere in its ancestry.
Okay, having to do with the prototyping system?
Yeah, so if you're inheriting from a bunch of objects, it just goes up the chain of objects and says, is it anywhere in the chain?
Right.
Has own property checks to see if it's in that actual object without going up the chain.
Right. So it's like a has method or something like that.
Something like that.
Yeah. Exists.
So
yeah.
Enumeration. My object is an empty object. Object.define property on my object. We're going to define A. We're going to say it's enumerable and it has a value of 2. And I'll see it's normal. So we're going to define another property B, and we're going to set enumerable to false, but a value of 3. So if we say my object.b, you get 3. If you say B is in my object, you get true. If you say my object has own property B, you get true. But if you say for var k in my object, console.log k, my object k, you get A2. You don't get B.
Huh.
So.
Okay.
Yeah. So that makes sense. I can see use cases for that.
Yeah.
So here's the problem with this. Like, I get that objects are about mixing state and data, but this is too much mixing for me. Yeah. I don't want to have to explicitly define, like, when you iterate through my object. Like, I want data objects. You know what I mean?
Yeah.
Like, I want structures that are for storing data, and I want, objects to contain logic and a little bit of data. The way this is scary to me.
Yeah, I could see that. Anytime it seems like there's a whole lot of really individually not overly complex, but when you put them all together, really complicated rules going on with JavaScript objects.
A lot of unintuitive things happening.
Yeah.
So it's like I can remember this rule and this rule and this rule if they're like edge cases that are going to bite me in the ass every once in a while. Like, every language has this. But when there's a ton of edge cases all over the places on things like arrays that everybody uses all the time, that's not good. So, okay. So this is the same as before on the left. We just have a little bit more information on the right. So we do my object.property is enumerable, A, get true, B is false. So that's how you tell if a property on an object is enumerable or not. So if you do object.keys and you pass it my object, you get A. But if you say object.getOwnPropertyName and you pass it my object, you get it back A and B. So keys is like part of the keys, I guess, uses the iteration, iterates through the object and gathers up the keys.
Okay.
B isn't part of that iteration because it's not enumerable, then it doesn't get it.
Okay.
So that seems like object.getOwnPropertyNames would be your go-to then.
Yeah, it does.
Unless you're like explicitly trying to do enumeration.
Yes.
So, okay, here we go. For arrays, iterating over the values is generally done with a for loop, but ES6 adds iterating over the values directly, which I like. So okay, here's the example. So my array is 1, 2, 3.
Okay.
So here's the old style. For var I equals 0, I is less than my array dot length I plus plus, and then console.log my array I. Normal.
Gotcha.
It's a for loop.
Okay.
My array equals 1, 2, 3. For var v of my array console.log v.
Which is more like a for each in some languages, but it's the same idea.
Yeah. So, but I like that.
Yeah, I like that method better too.
Yeah. And then here we have a little bit on the far right with symbol. So my array equals 1, 2, 3. Var it equals my array symbol dot iterator, and then we say it dot next, and we get.
Oh, this is VB style. I hate this.
VB, Visual Basic.
Yeah, they like doing this where you have this cursor that kind of steps through your object and you reference the properties and then you move on to your next. It's kind of like, do you remember those books that they used to have with the wheel and you could spin it and like there would be like an eyes on the page and when you spin it around it would be like different eyes that showed up behind it. Like the page looks the same but it changes because you're pulling something around behind the scenes.
Yeah. Okay.
That's what this is, and I don't like that style at all.
So you can do stuff like this in other, you can do this in Ruby, something like this, but nobody does.
Like record.next or whatever.
Yeah, but nobody does.
Yeah, it's awful.
Yeah. Why would you do that when you could just
iterate? Yeah, exactly.
Iterate. Yeah, that's what enumerables are for.
Yes.
Yeah. I'm sure there's some use case for this, but it's not going to be something I do very often. Okay, iteration. My object, we're going to have A2 and B3, and they do, so this got messy. Object.define property, my object, and symbol iterator. And we say enumerable is false, writable is false, configurable is true, value, function. So we give it this function as the value.
Okay.
No, symbol iterator is, so, and then, maybe, I need to go back and look again. Maybe he's saying that, I don't remember what this was doing.
Okay.
Return value OKS index plus plus done index is greater than ks.length. Oh, maybe he's just showing how you can actually like define an iterator value on the object or something like that. Like you could say like, you can actually like define an iterator reference on it so that like it has an iteration of, has something you call when you want to iterate through it.
Okay, and that could be useful if you have a large set and you don't want to have to maybe pull them all ahead of time so that you can walk through the values in a memory conscious sort of way.
Yeah. Or maybe he's showing, I don't know. I don't remember in here. I know that for of is fine. For var v of my objects is console.log v. Maybe he's just showing how you can get the same kind of behavior with that. Okay, so yeah, that was the end of the chapter. I was getting kind of shady by the end of the chapter with my slides. Sorry. Review. Objects have literal and constructed form. Okay. Objects are one of the primitive types. Okay. Objects are collection of key value pairs. Sure, for the most part. He doesn't give places where that can bite you in the ass. There's a reason why JavaScript has a hash map now. Let's just put it that way.
Okay.
And then objects have properties that can be configured. Okay. And then you can iterate over values and data structures as of ES6. Yay, iteration. Chapter 4. Chapter 4 won't be as long, but I know we're running a little long tonight. Sorry. We're already an hour in.
That's fine.
Mixing up, quote, class objects. So in many languages, a class is something that packages up data and behavior together. So string with a down case, and then it can be instantiated. So you know, you have a new string object or whatever. It also can be inherited from and be inherited by other classes, where it gains or gives behavior. You know, this is simple class inheritance theory. And then polymorphism, methods defined on the child class can override or not the methods defined on the parent class. In many cases, we can use the parent method, but add it to it with behavior from the child. Actually, that should say super in Ruby, not yield. Sorry. Right. Yeah, I meant super there.
That's okay.
I think that was getting close to lunchtime when I did these. Doing this in JavaScript is a recipe for disaster.
It's a recipe for disaster in every other language too.
Well, so okay. So, yeah, there are ways in Ruby to use super. We went over this with Sandy S's book, where like it's super useful and helpful.
Yeah, it can.
And, like,
it can be.
You actually don't even define like the constructor method in your child objects. You like use the parent to you use super inside the constructor and that kind of stuff.
Yeah.
So there are use cases for class inheritance, just not in JavaScript apparently.
Yeah, I mean, I'm not saying there aren't use cases for polymorphism. It turned out to, yeah, it gets dangerous quickly.
Okay.
And I almost always define my base class incorrectly, and so I try to avoid it if possible.
Yeah, fair enough. So JavaScript classes. Well, JavaScript has some syntactic elements like new and instance of, and since ES6 it has the class keyword, that's not to indicate that JavaScript has classes in the traditional class inheritance sense of the term. So class mechanics. In many languages, data structures must be instantiated and have a set of defined methods for interacting with the data hidden inside. So Ruby, Python, they're both that way. Classes are like the blueprints, and an instance is like the building. You can use the same blueprints over and over to create the same type of building that might contain different contents like furniture, aka data. The classes have a constructor that initializes an instance of a class with any state it needs to do so.
Okay.
That's normal. This is how classes work in sane worlds.
Yes.
Class inheritance. Classes can be parents and or children, and he's like, this is what, like, he was like, imagine that JavaScript really had class inheritance. Like, this is what you would have, like a vehicle class, and have one engine, and it has an ignition that outputs turning on my engine, and drive.
The good old car example.
Yeah, drive calls it ignition, and it outputs steering and moving forward. Okay. So, and then you have cars. You have cars and speedboats. So, you know, cars have 4 wheels. When you call drive, you would do like super, and then on the drive method or drive function, and you would then output rolling all wheels.
Yeah.
Okay. And then speedboat, you know, you got 2 engines on the speedboat, so it overrides the engines.
Yeah.
And your ignition you would override ignition, but you would do what is essentially super for drive, where you would call drive and then add to the end of drive the output.
Yeah, this is your typical situation where you start getting craziness going on with inheritance.
Yeah, well, this all makes sense though. Like, this is like this is how class inheritance works in languages where you have class inheritance. Yeah. None of this works in JavaScript.
Okay.
So polymorphism. Both car and speedboat use the vehicle drive method inside their own defined drive method. In most languages, that would be done with super. Until ES6, there was no real way to do this with JavaScript.
There was no super?
until ES6. Yeah. Quote, don't let polymorphism confuse you into thinking a child class is linked to its parent class. A child class is set to get a copy of what it needs from the parent class. Class inheritance implies copies.
Huh, okay.
So, yeah. Oh, and then you have the multiple inheritance problem.
Oh, yay.
A well-known problem in class systems.
Yep.
Mixins. So JavaScript doesn't do any of this. There's no copy made.
Okay. That's just funny. It calls out mixins and then it's like, oh, by the way, we don't do this.
Yeah. There's no copy made when you inherit or instantiate a JavaScript object. There's only the one object that all references point back to. Instead, some JS developers fake inheritance. So this is an example of explicit mixins.
I don't even know if I want to understand this.
Well, as you can see, it's big, messy code trying to get the behavior. And it doesn't even get you where you want to go. And then you have mixing copies. So alternate mixin, it's less safe. So this is that only copy if not already present, blah, blah, blah. And then alternate mixin, less safe to overwrites. So first create an empty object, and then you do vehicle stuff, you copy vehicle stuff, and now you copy the extended contents into the car. It's, but it doesn't get you. And then this is called parasitic inheritance,
which sounds awful.
Yeah. You have the vehicle, and then you have the vehicle.prototype.engine equals this function, and then the vehicle prototype.drive equals this function, and then you have a car function, and you have var car equals vehicle, new vehicle, and then car.wheels equals 4. And anyway, get all this. This car function, since car is a function now, not an object, car could be called without the new keyword, and the functionality would be identical, but without the wasted object creation and garbage collection.
So this is a factory, essentially, right?
Yeah. So like you can call without you, but you don't ever need to call new car.
Right, because we call the function, and the function returns the car because the function's acting as a factory to build that object.
Exactly. So like, why bother?
Yeah.
So and then we have implicit mixins. Var something equals cool, and then you got a function. So something.cool, something.greeting, something.count. And then you have another cool explicit mixin of another of something to another. So you have something.cool.call this, another.cool, another.greeting, hello world, another.count one, not shared state or something.
Okay.
So, yeah. And then, so, and now, yeah, like I said, this one wasn't going to take nearly as long. Classes are a design pattern. Classes mean copies. JavaScript doesn't create copies. It creates copies of references. Mixin pattern is used by some to get around this, but it makes brittle or hard to follow code, which is why I didn't bother trying to follow it too closely. And then he talks about a ton of different gotchas in the code in all three of those approaches. Like none of them get you entirely what you want, and all of them have gotchas. And
so if you're using a lot of JavaScript, you probably want to understand how it works because you'll probably run into it, but you might not want to consider it for your own code.
Right.
Okay, fair enough.
And so lots of gotchas, more trouble than it's worth in JavaScript. That's the end of time. And how do I stop presentation? There we go.
Cool.
And I'm still presenting to everyone.
You sure are. Let me fix that.
So what do we got? So are we cutting it off here, or are we going to move forward?
I don't know. I don't have a whole lot of time to make slides and stuff right now.
Okay.
So I
I
don't
think at
feel
this
right.
point we had decided we were going to get to this point, and then what was the next chapter? Oh, prototypes. So,
Okay.
but maybe we should like take a break and do something like to get some more people involved, like start a new book for a while, and then maybe come back to this one.
Okay.
So, do you want to like cut the call and then maybe discuss that?
Sure. That sounds good.
Cool. So, call it a night.
So, good night, everyone. Glad you joined us.
Thank you.